Hey everyone, and thanks for joining me. Today, we're taking a brisk but memorable tour through 8 design patterns that can turn a just works prototype into a maintainable, scalable, and testable product. Patterns give shared names to solutions we've all reinvented, so your team can discuss architecture instead of arguing about variable names. I'll cover 3 creational patterns, 2 structural patterns, and 3 behavioral patterns. Then finish with a quick cheat sheet you can screenshot. The goal isn't to memorize UML, it's to recognize the smells that tell you a pattern might help and to understand the trade-offs each one brings. And if you find this helpful, please like, share, and subscribe for more tech videos. It really helps the channel grow. Ready? Let's dive in. First up, the only pattern that literally enforces loneliness: Singleton. Picture an application-wide logger or configuration registry. You need exactly one instance accessible from everywhere. The Singleton hides its constructor, stores a static reference to itself, and hands back that single copy on demand. It feels convenient, but remember, global state hides dependencies, complicates testing, and can bite you in multi-threaded apps. Use it sparingly, document it loudly, and prefer dependency injection when you can. Singleton is a quick fix, not a lifestyle. When object creation sprouts large switch statements, reach for factory method. A superclass defines create product, but subclasses decide which concrete class to return. Think of a document editor where each format, text, spreadsheet, or vector art, spawns its own page object. The factory localizes construction logic while letting the rest of the code treat every page polymorphically. You trade a few extra subclasses for cleaner open-close flexibility and sharper separation of concerns. Scale that idea from one product to families and you get abstract factory. Suppose you're building a cross-platform UI kit, Mac OS buttons, Windows buttons, Linux buttons, each with matching scroll bars and menus. An abstract factory spits out the entire widget family in one call, guaranteeing visual consistency. Swap factories at runtime, and the theme changes like magic. The downside? More classes than you can shake a stick at. Code generation tools and discipline namespaces are your friends. Some objects need a shopping list of options. Enter Builder. Picture constructing a house where the client picks bedrooms, garage, solar panels, and smart locks. A builder offers fluent step-by-step calls. Add garbage, add solar panels, and finally, a build method that returns the finished house. You gain readability, immutability, and sane defaults while keeping construction logic separate from the object itself. The price is an extra layer that can feel verbose for simple cases, so reserve it for genuinely complex creations. Legacy code rarely fits the slick new interface you just designed. Adapter acts as a translator between incompatible APIs. Need your modern payment processor to talk to an ancient XML invoice service? Wrap the dinosaur in an adapter that exposes the expected methods while internally mapping calls and formats. You avoid rewriting battle-tested code and buy time for a proper migration. Remember though, every adapter is another object to test, trace, and maintain in production. Cross-cutting concerns, logging, caching, and encryption are where Decorator shines. Instead of building big fat service with everything, you compose behavior at runtime by wrapping objects. A plain data source can be wrapped by compression Decorator, then by encryption Decorator, each adding its feature before delegating. This keeps classes single purpose and combinations flexible. On the flip side, debugging a deep Decorator stack can feel like peeling an onion, tears included. So, invest in clear naming and logging. Algorithms that vary at runtime belong in strategy. Take a sort context that might use quicksort for small arrays, merge sort for large, or even GPU-based radix sort. Each algorithm lives in its own class, implementing a sort interface. The context decides which to use. This follows the open-close principle. Adds a new algorithm without touching old code. The catch? You now have to inject or choose the strategy somewhere. so your client code must handle selection gracefully. Finally, the darling of UI frameworks, Observer. A subject keeps a list of observers. When its state changes, it notifies them. Your model emits a stock price update, and every chart, label, and notification tray reacts automatically. Observers decouple the broadcaster from its listeners, but they can cause cascading updates or memory leaks if you forget to detach in long-lived systems. Treat it like event wiring, powerful, but respect the circuit breakers and keep an eye on performance. Those are our 8 patterns: Singleton, Factory Method, Abstract Factory, Builder, Adapter, Decorator, Strategy, and Observer. They're not silver bullets, just reusable conversations that encode hard-won experience. Next time you spot global state, tangled object graphs, or runtime algorithm switches, pause and ask which pattern maps to that shape. Start small. Refactor one isolated component. Write unit tests to prove the benefit. Then evangelize the pattern to your team. Thanks for listening, and happy designing.